Alright, and welcome to Unit 3, Lesson 7 on the force of friction. In this lesson, we're going to be going over example number 1. And a little bit before we get going, though, I'd like to dip into discussing the formula itself for friction. So I have it written up here. The force of friction, force with little f, is equal to the coefficient of friction times the normal force. Now, we did normal force in the last topic, so if you need a little bit on that, go ahead and check it out. Coefficient of friction, however, we haven't talked about yet. And really all this is it's some value that denotes how rough the surface that we're sliding, or the amount of roughness between the surface and the object that's sliding upon it. It's a better way to say it. This usually ranges from a value of 0 to 1. Oh, not 0 to 0, 0 to 1. Where 0 would be a perfectly smooth, frictionless surface. And if we multiplied our normal force by 0, well, we would get 0 friction. As opposed to if we had a value of 1, I mean, every bit of normal force would translate to force of friction. That said, coefficient of friction can go beyond 1. We can have extremely rough surfaces that require more force to drag something along them than that object's weight in newtons, the force normal. Okay, so let us, with that out of the way, begin this question. So the question says we have a 37 kilo object, which I've quickly sketched here, is being pulled east by a 400 Newton force. So let's sketch that on here. Here's a force. We can call it just force 1, I guess. You can get more creative if you want. It's equal to 400 newtons. The coefficient of friction here, I have written that up between the object and the surface. So the force of friction will really be between these two surfaces is 0.68. Alright, we are to determine the acceleration of this block. I think that's a task that we are pretty ready to handle here. So let's fill in all of the forces on our block first, because there's going to be a few going here. Now, first thing first, we're going to have force of gravity, of course. Force of gravity will pull this thing downwards, so we can call this Fg. That's going to equal mg, right? Mass times gravity. We'll get to that later. We have counteracting the force of gravity. We have the normal force, so Fn, pushing upwards. And then moving in the direction against the acceleration. So the only real force acting on this block is to the right, so the net force is to the right, meaning that we're going to have some sort of friction opposing it here. Alright, so let us move on. Well, first we should label that. We'll call this force of friction right there. Okay. Well, I think what we should do is realistically we should start by starting with just our friction formula and see what we're going to have to solve for. So ultimately we're going to end up getting something like this. Force of friction is equal to coefficient of friction times the normal force. Well, we're given this, that's awesome, but the normal force we are not given. It's in the y value, so we're going to have to solve for that. How are we going to solve for that? Well, we have to solve y direction and then we can come back to the x direction. So let's choose a new color, maybe red, and let's figure out our force normal. Well, in the y direction, we have no acceleration. So we can say to ourselves that F net y is equal to mass times acceleration. But this acceleration value is 0, and anything times 0 is 0, so F net y is equal to 0. All right, so that's one little bit out of the way. Then we can also do the second Fnet formula, saying that Fnet, or at least in the y direction, is equal to the sum of all the forces in this direction. So that gives us force normal plus force of gravity. And if we want to fill some values in here, we're going to have 0 is equal to force normal plus our mass, Fg, Fg is equal to mass times gravity. So this is going to be 37 kilos times acceleration due to gravity, negative 9.81 meters per second squared. So if we work that out, normal force here should equal, I get 362.97 newtons. 362.97 newtons. That's a useful value for us, because now we can determine what the force of friction is here. All right, we've got normal force, which can feed into there. So let's get our blue marker out here again and say that, I'm going to drop this down so there's a little space, that force of friction is equal to our coefficient of friction, 0.68, times 362.97 newtons. All right. That leaves us with a force of friction of 247 newtons. All right. So we've just used the y value to solve normal force, and then normal force in our friction formula to solve for friction. Now we have a mass, and we have a couple forces acting on it here. We can jump maybe to a new color. Let's go magenta again and say that in the x direction, F net x, the direction that this thing is being pulled in, we can say is equal to the sum of all the forces. So force of friction plus force 1. And we have both of these values now. So we can say F net x is equal to, force of friction here is going to the left. And in this case, I think I will make left negative, right positive. So force of friction is negative 247 newtons plus 400 newtons, which leaves us with a net force in the x direction of 153 newtons. All right, so we are getting close to having this thing solved. We now have a net force, we have a mass. We can go back to our old school Fnet formula, where Fnet is equal to mass times acceleration. We have Fnet, we have mass, let's solve for acceleration. So we can say acceleration is equal to Fnet over mass. Well, we can say that Fnet, or acceleration, sorry, is equal to 247 newtons over our mass, which is 37 kilograms, leaving us with a final acceleration value of 4.1 meters per second squared. And that is the beginning of friction in a nutshell.